Hi everybody, let's look at blockchain through the eyes of Python. A blockchain is a distributed ledger that allows us to have a non-repudiated connection of transactions. This you could think of as the Genesis chain, the Genesis block. There is no previous block, so the hash is going to be 0. In this block we store the data, the hash of the previous block, and the hash of the entire of the transaction. When we chain on another block, we take this hash this guy, and that allows us to make sure that this one is connected to this. This hash allows us to connect to this. So as we go further down the line, we can always back up because this hash will match this hash will match that. This hash matches nothing because that's the beginning of our new cryptocurrency blockchain that we're inventing. We're going to mine cryptocurrency. Well, not really, but we can pretend. So this is a distributed ledger type of technology. It does not have to be in one place. Anybody can have a copy of this and go back and make sure that it is all good. Each block contains a transaction, and each block has a hash and is linked to the previous block through a cryptographic hash. Cryptographic hash is a unique digital signature. It's actually a one-way function that allows us to we can't find out what the transaction was based on that hash. It is unique so that it identifies each of our blocks as a unique block. We are going to mine. You're not going to be rewarded with a good grade if you get through this and understanding of blocks and mining. Well, let's take a look at some code. We start out with the basics of a block. Transaction 1 is a block. We take transaction 1 and put it in our Genesis block and we're complete. Blocks, for our purposes, are tuples. So we've started by creating a very simple Genesis block. That's our transaction. Wallet 1 paid 1 Bitcoin to Wallet 2. By the way, at the end of this, I'll give you my Bitcoin wallet, and then you can all send me some Bitcoin. Nope. Okay, so we need a hashing function to connect our blocks together. So we take a bithash function using hashlib. The information coming in is a tuple. What we return is a string, which is an hash of the transaction in hexadecimal. So we make sure that our data is a string, just in case it isn't. We encode this into bytes. Hashing works on bytes. It works on a bit stream or bytes. We take that byte data, compute the hash of it, then we turn it into a hex digest so that we can see it and understand it. That becomes a bit hash hex. We return the resulting hexadecimal string. We are returning hexadecimal strings and showing what the hash is for our demonstration purposes. In an actual blockchain, you wouldn't necessarily see this in hex. You might be comparing the byte string, the bytes. So here's our transaction 1. We have our Genesis block hash. We bit hash the transaction 1, and we have a Genesis block hash. Now we create our Genesis block with the hash of the Genesis block. This is our 0, meaning this is our first one. This is our transaction. So now we have our first Genesis block, more or less. There's our number, which is like the first 0, meaning it's the beginning. There's our transaction. There's the hash of our transaction. All right, let's move a little bit further. We're almost to actually doing a blockchain. Well, the bit hashing piece stays the same through the rest of this program. We always have to hash things. So we're starting with a transaction. We're hashing that transaction. We're recreating the Genesis block, or recreating. I don't know why it says recreate. It should be create. Create the Genesis block. Now we have hashes in our chain. We print that. Now, let's create a transaction for block 2. Well, our block 2 hash is going to combine our previous hash, the one we created up here, to our block 2 hash. And we end up with the first hash, our hash, and the transaction. So now we can track back to the Genesis block. We can track back to this block if we make another block. And there she blows. Now this is the hash of our Genesis. Notice it starts with A, right? Well, here is our second one. It starts with our first hash, the transaction, and its own hash. Now we're almost ready to do the whole thing and actually get some Bitcoin minted here, or mined. To do that, if we're going to create a bunch of Bitcoin, we need another method. To create a block, we need a prior block hash, which is going to be a string. We need a prior block number, which is going to be an int. And we need some transaction data. Whatever the prior block number was, we're going to increment it by 1 for our new block. So if the first block is 0, this block is going to be 1. Now we hash the prior block hash, the current block number, and the transaction to data. We create a block hash with that. Now we create our new block. Well, we put our prior block hash, block number, transaction data, our current block hash into this new block, and now we have a newly mined piece of cryptocurrency. All right, so here's our first one. The prior block hash is 0 because there isn't one. Prior block number is -1 because there isn't one. There's our transaction data. We create our block and we print it out. So far, so good. All right, so our Genesis block is going to be our prior block for our loop. Now, if you look at our prior, let's see, 1, 2, 3, 4. So it's going to be 1 and 3. Block number, block hash. Block number, block hash. We pull that information out. We have the block hash and the block number from the prior block. This is actually block plus 1, which would be block 2. We get our prior block hash from the previous block. We're going to just increase the amount of Bitcoin that we're paying just to show each transaction is different. Then we print the details of the next block, and then we update the next block to the prior block, and then we keep going. 3 times, we end up with a series of Bitcoin transactions. Notice this one ends in 5, ends in 5, ends in B, ends in B, ends in 0, ends in 0, ends at 9. We don't have any more blocks. So notice how you could trace back to each previous version, and we have a distributed ledger of transactions. And by the way, everybody owes me 4, 7, 8, 9, 10 Bitcoin. I could retire on that because Bitcoin is pretty expensive right now. Well, I hope you understood that. This is a demonstration of how cryptocurrency and other blockchain transactions work. Blockchain transactions are also used in other areas besides Bitcoin. Do a little research and find out.